Okay, Geometry AB, we're going to move on into Chapter 11, Section 4, and we start shifting gears a little bit now and get into the concept of volume right here as opposed to surface area. The good news for you guys, I think, though, is that the concept of volume is actually much easier for most people to deal with than the concept of surface area. So we're going to start off today talking about the volumes of two shapes, prisms and cylinders. These are the same two solids that we did in Section 11.2 the first time we started talking about surface area. And as I think you're going to see, these formulas are much easier. So the formula for volume of a prism here is just capital B times H. The one thing you have to watch out for is that capital B actually means something a little bit more complicated than people think that it means. It doesn't just mean base. The capital B means the area of your base, and that gets pretty important here. The H, though, still represents the height of the prism, and just like we talked about height back in the beginning of this chapter right here, the height of the prism is not always measured vertically. Very often it is, but not always. The height of the prism is really defined then as the distance between your bases. So let's remember that important idea, and I'm going to try to use that terminology as much as I can as we're going through trying to explain the way this works. But this is the one nice formula here that's going to help us here for volumes of prisms. Not too bad of a formula. So let's take a look at what's going on. And if I'm not mistaken right here, guys, I think that this shape that I've given you right here is identical to the formula, to the solid that we drew at the beginning of our 11.2 notes when we were talking about surface area. It's basically a cereal box. And the formula we've got to use now to come up with volume is capital B, which means area of the base, multiplied by the height. And I actually want to do this problem a couple of different ways, because one of the cool things when we're talking about rectangular prisms, which this one is, you actually have a lot of options. So let's think about how this might work out. When we think about where the bases of a prism are, remember that the bases of a prism are going to be two congruent and parallel shapes on opposite sides of the solid. Now, most of us want to think of the base of a solid being located down on the bottom. And before we make that distinction for sure, if we were going to say that this was going to be the base of that figure, there would need to be a congruent and parallel rectangle on the opposite side of the figure. Well, sure enough, there's one right up here on top. And if you think about a cereal box, the bottom and the top rectangles are exactly the same size, exactly the same shape, and they're parallel to each other. So there's no reason we couldn't let that purple rectangle be our base. So then, volume would equal, all right, remember now that capital B means area of the base. We know that this side of the rectangle is 9. This side over here, which is parallel to this one right up here, is still going to be 2. So we'd multiply the 9 by the 2 to get 18. For the area of that base. Now, we just multiplied inches times inches, so our area right there is technically 18 square inches. We would multiply that by the height of the prism. And remember, everybody, that the definition of height is distance between your bases. So if our bases were at the top and the bottom of the figure, then this vertical dimension, this measurement right here, which is the 12-inch side there, that would be your height. So the 12 inches goes right here for height. And now we would go ahead and multiply those two together. And the 18 times the 12 is going to get us, I believe, 216. I better double check that. 18 times 12. Yeah, sure enough is 216. And something interesting happens with units now. We're multiplying square inches from the area of the base times inches for the height. And when you multiply square inches times inches, you get a new unit here we haven't used before called cubic inches. And that is going to be the measurement here for the volume of that particular cereal box. Now, you can stop paying attention right now if you want to just move on to the next problem. But what I find interesting here is you can actually do this a couple of different ways. If we wanted to, if we were so inclined, we could do the exact same thing again, but now take advantage of the fact that with a rectangular prism, you could use the right side over here, which I'm going to shade in red, as a base, because there's a congruent and parallel polygon base over here on the opposite side of that figure. And if you wanted to look at it that way, the area of this red base, well, it's 2 by 12 here, so 24 square inches is the area of that base, the right side of your cereal box. And then the height, the distance between the bases, would now be this horizontal piece right here, which is 9. So if you flip the box around and looked at it a different way, you'd get some different measurements. But the cool thing about this is when we go to the calculator and multiply 24 by 9, we still end up with the same 216 cubic inch volume that we got using the bottom and the top as the bases. And of course there's a third way too. If you kind of knock the cereal box over so that it was sitting on its front side and let this whole rectangle here be your base, that would work out as well. You'd multiply the 12 times the 9 right here to get 108 for the area of your base. This 2 then becomes your height, and the 108 times 2 gets you the same volume of 216. So you can actually do this problem 3 different ways, and every time you do it, you're going to come up with the exact same answer. All right, but things get much harder once we move away from rectangular prisms where we don't have as many options. And as I told you guys last week when we were doing surface area, this particular problem here with a triangular prism is a really great test for whether people understand what a prism is and how it actually works. A lot of people want to look at this and say, okay, the figure, this wedge or this block of cheese or whatever, is kind of resting on this rectangle down here on the bottom. So that's got to be the height, the base, and this 7 centimeter side over here has to be the height. And that is not the correct way of looking at this figure. The reason that rectangle on the bottom isn't the base is because there's no congruent and parallel rectangle up on the top on the opposite end of that figure. So what we're going to do here in our triangular prism is we're going to recognize that there's a triangle over here on the left-hand side that looks like this, and another congruent and parallel triangle over here on the back side. That means that this is actually your base, or actually I should say that these 2 triangles are actually your bases. And the distance between those 2 triangles, which is this 10 centimeter side right over here, that becomes the height of your prism. So just being able to look at this one correctly is kind of tough. All right, guys, so volume of a prism is equal to capital B, area of your base, multiplied by your height. So volume is going to be, and here we go, we need to come up with the area of that yellow triangle. So the area of our base, well, the area of every triangle is 1/2 times its base times its height. And anytime you're dealing with a right triangle, you always just want to use the 2 legs, because they're perpendicular to each other, for the base and the height. So in trying to find capital B, I don't know what this base is right down here, but the height sure looks like it's going to be 7. So we'll put that 7 right in there. Well, this diagonal over here was 25, which means that this one is going to be 25 as well. And if we wanted to find B right here, we could do the Pythagorean theorem on that. It would look like 7 squared plus B squared is equal to 25 squared. And when you do that, I'm going to skip this work here and let you guys do that on your own. We're going to end up with little b being 24. So putting all that into the calculator right there, you're going to end up with a 12 times 7, which is going to be an 84 for the area of that triangular base. The height then, we said, is the distance between those 2 bases, so that height is going to be 10. And the volume of this triangular prism then is going to be 840 square centimeters. Cubic centimeters right here, because we're talking about volume and not surface area. I think we're going to skip this problem right here, guys. That was one I did with my other geometry class. Okay, I'm going to stop the video right there, and we'll come back and we'll finish the rest of this up in just a minute.